Namaste. In this video, we are going to see the properties of regular languages. So the properties for regular languages L1 and L2, we will prove that L1 union L2, L1 concatenation L2, and L1 closure, L1 reversal, L1 complement, L1 intersection L2 or regular languages. The resultant languages with these operations will also be a regular language. We are going to see that, and we can also say the regular languages under these operations, or regular languages are closed under these operations. So regular language L1, let me consider, and also regular language L2. So the language accepted by M1 is L1 and language accepted by M2 is L2. So for example, let me consider this is the automata with single accepting state. Then the first operation, it is nothing but L1 union L2 will see. Let me consider one example where L1 is nothing but a to the power n b. So the NFA will be any number of times a, then b. And the other example is BA. So this is the example. So we'll see the union of it. So how to construct union between these two is both the machines you consider and add a epsilon transition from an initial state, and also consider a new initial state. From that add a epsilon transition or a lambda transition, and what you can do is next, so the same example, next what you have to do is, and I'm having here two acceptance states. So this is for union. Next we'll see concatenation. In this case, how I can concatenate two languages, that just add a epsilon transition between these and also a epsilon transition to this. So this will give you the concatenation. So what I have to do is, one example for that, a to the power n b, and one more example is BA. So add a epsilon transition, then add a epsilon transition. Next we'll see star closure. How I have to consider is the automata. So before the automata, add one initial state and add a lambda transition, and after the final state add a lambda transition, and from the final state to the initial state one lambda transition, and from the initial state to the final state one lambda transition. So this is the star closure for given language. Next operation is one example for that. The language taken is a to the power nb. So we have already seen how to write the automata for this, and how to write the closure for this is add a lambda transition from the initial state, next add the lambda transition from that to the final state newly constructed, and add a lambda transition from the final state to the initial state, and also from the initial state to the final state. We'll see the next operation. It is reverse. So how to find the reverse is just simple. Make your initial state as final state and your final state as the initial state. So example for that, if I write a to the power nb, then your L1 power r, that is string reversal or language reversal, will be b a to the power n. Next we'll see the complement operation, where how to find is, take the final deterministic finite automata that accepts L1. You have to consider, for complement you have to consider deterministic finite automata, make the final states non-final and vice versa. So just change the final states. Why not NFA? So in NFA you have to consider many things. So what you can do is, you can convert the given NFA to a DFA, and then you can do this process. So example for that, they have taken a to the power nb. So what you can do is complement from the universal set, you have to difference this value. So you'll be getting the complement. Next we'll see the intersection between the two language. So intersection, so according to the De Morgan's law also we can prove, that is L complement union L2 complement, the whole complement. We have already seen complement is also a regular, L2 complement is also regular. So if I do union between them, that is also regular. If I take complement for that, again that will also be regular. So I am going to consider a to the power nb and ab or ba, two languages. I am going to do intersection for both. How I can do that is, how you have to do is, you have a set of procedures how you can for doing this. What you have to do is, you have to consider, you have to start with the initial state. You have to club the states. If I have 4 states, then what I have to do is, I will be having all the combinations. So here 2, here 2. So Q1, P1, Q1, P2, then Q2, P1, Q2, P2. So 4 states I will be getting. Here 2, here 2. So totally I should have 4 states. And the initial state will be here Q1, P1. So initial state of the constructed automata will be Q1, P1. And the final state will be final state of this, and final state of this will become the final state. And the transition, how I have to add is, if I have a transition on A from this to this and also from this to this, then only I should add the transition. Here I have a transition A from Q1 to P2 and P1 to P2. So I should add the transition from Q1 P1 to P2 Q2. And the next step is initial step, construction of the initial step, that I have already told. Next, the construction of the final state, this also I have already told. So here one final state and here you have 2 final states. So Q1 Pj will also be a final state, Q1 Pk will also be the final state. So the language how we are going to do is, M simulates in parallel M1 and M2. M accepts string W if and only if M1 accepts string W and M2 accepts string W. So L of M will be L of M1 intersection L of M2. So I am considering these 2 languages where a to the power n b and a to the power m, sorry, a b to the power m. So the language L2 in L1 intersection L2 will be, so the automata for this language is this and for this language is this. It's nothing but any number of A's followed by B. After that trap state is added, and here a single A followed by any number of B's and the trap states are given here. So we'll see how many states are here. So Q0 with P0, P1, P2. Next Q1 with P0, P1, P2 and Q2 with P0, P1, P2. So all the states I have to add. So totally I have got 6 states. Next all transitions I have to add. Q0 on A, Q0 P0 on A, it will reach Q0 P1. So like that, if you keep on adding the transition, you will get the automata where it will read only AB. Thank you.